So corresponding parts of similar figures. So this is an extension of scale factor and what we've been working on. Today's the 24th. You can't see any of that. Here we go. Corresponding parts of similar figures. So when we were looking at scale factor in the last unit and we were comparing parts, what did we compare? And we were looking at scale factor and we were comparing parts. What did we actually compare? The side lengths, right? So you looked at a figure, whether it was a sphere or a triangle or a rectangle, and you compared side lengths. So that was one thing we compared. We're going to look a little more specifically at similar figures in this unit. Those side lengths, just like in the last unit, have to be proportional. So that's where we set up our ratios and we reduced our fraction and got a scale factor. And remember, when all the scale factors are the same, the figures were similar, and when they were not the same, they were not similar, right? Okay, so side lengths still have to be proportional, are proportional. And now we're going to look at this unit at angle measures. So if figures are similar, we're going to get even more specific, and their angles have to be congruent. And what does congruent mean? Equal. Okay, so not only do the side lengths have to be proportional, but the angles have to be congruent. If both of those things don't happen, the figures are not similar. Okay, so let's draw. I know it's your favorite. Let's draw this figure here. And it's not perfectly drawn to scale because we're not perfect, but we'll make it work. And I'm going to compare it to this figure. Okay, so here are my two figures. I'm going to figure out if those two figures are similar. So in the last unit, we dealt just with side lengths. Here we're going to look at side lengths and angle measure. So give me another second to finish drawing. What can you tell me about the side lengths? Someone tell me something they know about the side lengths of figure A, B, C, D, and E, F, G, H. The side lengths. What do you know about the side lengths of these two figures? Let's start here. What do you know about the side lengths of figure A, B, C, D? They're all equal. How do you know they're all equal? Does anyone remember what those marks are called? From IM1. Think back to IM1. You know that they're equal. It starts with the letter T. Close. They're called tick marks. Oh yeah, remember that? Okay, so the tick marks tell me that all of those sides are equal. Okay, and they each have a single mark. What do you know about just figure EFGH and those side lengths? Those are all equal, right? Because they have the same tick marks. Now, because each of them has one tick mark, all of these side lengths and all of these side lengths are equal, which means they're going to be proportional. Okay? Now let's look at angle measures. So I know the side lengths are going to be proportional. What do you know about the angle measures in this first one? They're all 90 degrees. How do you know they're 90 degrees? They have the square, right? That tells you it's a 90-degree angle. Now these marks, when they're arced, they're called arc marks. Super creative, right? What do you know about the angles in the second figure? Only two of them are equal. Which two are equal? FH and EG are equal. Are any of those 90 degrees? No. So because these angles and these angles are not congruent to each other, these figures are not similar. Okay? And we're going to put a little extra information other than not similar so we know why. But the figures are not similar because the angles are not congruent. So the figures are not similar because the angles are not congruent. All right, let's try another one. We're going to look at two different triangles. And we're going to decide if these triangles are similar. So take a second and draw those. So again, we have to determine if they're similar by two things. All the angles are congruent, all the sides are proportional. Okay? Angles are the easiest to determine, right? If I would have started at angles here, I would have seen that these angles are not the same as those, and I could have stopped. So let's go through all of these angles. Is there an angle congruent to angle M in the other triangle? Yes. Which one? P. Okay, so angle M is congruent to angle P because they have the same markings. Are there any other ones that are congruent? Yeah, T and L. T and L, okay, so angle L is congruent to angle T. What about N and O? Yes, they are. Mm-hmm. Yeah, they don't have any markings, so that's fine. There's a theorem that you learned in IM1. Okay, so I'm going to have you think back again. If you don't remember, that's okay, I'll tell you. But think back. The theorem said that if two angles in one triangle are congruent to two angles in the other triangle, then the third angles have to be congruent. You knew she was going to say that. Does anyone remember the name of that theorem? Extra points if you do. I kind of already told you the answer. Okay, so if two angles in one triangle are congruent to two angles in another triangle, then the third angles have to be congruent. Before I even ask you the theorem then, why is that true?
Because all triangles add up to 180.
Exactly. All triangles add to 180 degrees, so if I know two of them are already the same, the third ones have to be. Last chance for the name of the theorem. It's called the third angles theorem. You're close. You didn't learn that? Oh, okay. So right now we have all the angles are congruent. What else do we have to show? All the sides are proportional. So what side matches with side LM? LM matches with TP. Okay, so what you have to look for, here I have a double arc, so I have to start at the double arc. I go to the single arc, I end at the single arc. So LM is going to be proportional to TP. What is the length of LM? 8. And what's the length of TP? 6. And what does that reduce to? 4 over 3. So that's my scale factor, but it's also showing whether the sides are proportional. Okay, let's look at MN. What would be proportional to MN? PO. Okay, so MN is 6. PO is 4.5. Does anyone remember how we deal with that decimal?
No.
We did it.
You move it to the right.
Okay, if you move that one to the right, you technically have to move this one to the right because that's the same as 6.0, right? So now I have 60 over 45. What number goes into 60 and 45?
5.
Higher?
10. 15.
15. 15 goes into 60.
Wait, I don't think
4 times, and 15 goes into 45 3 times. So right now I'm okay. I have to check that final side length. So what have I not used? How about NL? What's proportional to NL? N to L. O to T. Okay, it has to be the same direction. Okay, what's the length of NL?
12.
And the length of OT? And what can I reduce 12 and 9 by?
3.
Which gives me 4 over 3. Okay, so all the angles are congruent, all the sides are proportional, which means these two figures are similar. So we're just going one step beyond what we did in the last unit. Now, in IM1, when you were talking about congruencies, you made something called a congruency statement, where it said like triangle ABC is congruent to triangle DEF. Do you remember those statements? Okay, we're not talking about congruency here, we're talking about similarity. So we're going to write a similarity statement. So if I say triangle LNM, triangle LNM, what triangle is LNM similar to? How would I write it over here? So I did LNM. Where would I start? TOP. Good. Triangle TOP. So you need to make sure that when you write similarity statements, so I L and T match, so they have to be first. And then I went to O or N that had nothing, so I go to O that has nothing. And I end at P that has one arc. You need to make sure that when I ask you to write a similarity statement, it's in the correct order, like the orders have to match. Okay, that's really important. Are we okay with that? So what did we add different from the last unit? What did we add? Angles, right? Comparing angles. You've already compared side lengths. Do you agree? Now you're comparing angles. The difference from the last unit versus this unit is everything was lined up really nicely. Nothing ever kind of twisted, right? You were able to tell which one matched with which one. This one, you're going to have to look at the letters and potentially your similarity statement and your markings. Okay, that's going to be important. All right. Let's solve. Okay, so solving similar figures. Similar figures. We're going to solve for the variable, and we're going to go small to big. Oh, you can't see. What? It's frozen. Hold on. Stand by. Try again. Nope, still frozen. Okay. Close you. Open you back up. There we go. Solving similar figures, and we're going to go small to big. Now the nice thing about solving similar figures is that you're going to set up a proportion, and if you set up the proportion correctly, You should know how to solve it, right? We're pretty good at solving proportions. So as long as it's set up correctly, you're going to be okay, hopefully. So we're going to draw again. Yes. Should you be asking me that right now as I'm doing a lesson? Go. I'm almost done. I'll get my hand out of the way. Okay, there we go. All right, so if you look at this figure, how many triangles do you see? 2. Does everyone see 2? You should see the small one, which is triangle LRQ, and then you should see the large one, which is triangle LNM. Everyone okay with that?
Yeah.
Okay. So we're going to go small to big. You need to compare something in the small triangle to the same side length in the big triangle. So what could I compare that matches up? 14 and 91. Okay, so that's the bottom piece. So 14 to 91 match up. Now, I need x, right? I'm going to have this 14x minus 11. That's in the big triangle, so I know that's going to go on the bottom. What does that match up to in the small triangle? I think I heard it. It's going to be 22. Okay, so it's small to big and then small to big. Could I have used 24 and 156? Yep, you'll get the same answer. Instead of 1491, I could have used 24 and 156. As long as your proportion's set up, you should be able to solve it, right? Looks like we're going to probably need a calculator, though. All right, here we go. 91 times 22. 2002 equals 14 times 14 is 196, so 196x minus 154. Now it's just an equation we can solve. What should we do from there? 154 we're going to add to both sides, okay? So 2,156 equals 196x. Divide by 196. You should get x equals 11. Okay, so our answer is x equals 11. What if I asked you what the value of ln was? What is ln? How would I do that? You'd plug 11 in for x and solve. Okay, so if I want to know what ln is, once I know what x is, I can plug it in and solve. I'm not going to have you do that right now, but you did it. What'd you get? 143? Okay. So 11 times 14 minus 11 gives you 143. Okay, so we're going to compare small to big. You're going to see a lot of these problems. We're going to probably spend today and tomorrow on this. All right, let's try a different one. And you should be drawing the figures so that you know kind of what you're comparing. If you just have ratios, that doesn't do you any good, because that's not the hard part. Now my figures are not necessarily drawn to scale, Okay. But we're going to look at tick marks and arc marks to tell us whether or not things are similar. Also, as you're drawing too. So we went small to big in the last one. If we went big to small, the only thing that would happen is our fractions would completely flip upside down, but we'd still get the same answer. So it doesn't matter what order you choose to go. You just have to be consistent for yourself. So if you're going to go small to big in the first fraction, you have to go small to big in the second fraction. Does that make sense? Okay. So what do you think we can compare here? 91 and 21? Why'd you choose 91 and 21?
Because the side they both have like 2 tick marks.
Perfect. So they both have 2 tick marks, so I can compare it. So you want to go from right to left? Because you said 91 to 21? Sure. Okay. So someone else tell me what I would compare, but it has to be in the same order. So we went right to left. So what else can I compare? What else matches up between the 2 triangles? Good. Negative 11 plus 15x over 39. Awesome. Once it's set up, the rest you're good at. So we're going to cross multiply with our calculators. 91 times 39 gives me 3,549. And then 21 times negative 11 is negative 231. And 21 times 15 is a positive 315x. Where do I go from there? Add 231. Okay, so 3,780 equals 315x. Divide by 315, and you should get x equals 12. Do we get that? Okay, I'm going to let you try this last one on your own. Or with your group. Either one's fine. Yes, sir. Uh-huh. So because we went from 91 to 21 here, I have to go negative 11x plus 15 to 39. So we went right to left. I could have done 21 to 91, but that means this would be flipped and that would be flipped.
Okay, so like for the last one we did, that was because we went from left to right.
This one?
Yeah, the one before.
We did the small triangle to the big triangle. Here we went from right to left. So it doesn't matter what order you go in, you just have to be consistent. Okay? All right, last one. You're going to have fun drawing this. Ready? If you need to put it on your warm-up page, it's the last one you can. It's 2 triangles. Do you see the 2 triangles? Yeah, it's like a bow tie. It's just lopsided. Okay. So once you're done drawing, I want you to take a second and I want you to compare. You can go small to big, you can go big to small, you can go left to right, right to left. I don't care how you choose to do it. You just have to be consistent. So one more time to draw. I started in the bottom corner and went up, made a long line over, went up again, and then connected the two. Yes. This is a 56.
Oh, no, I see. I just see the glasses.
So 10x, 55, 56, and 44. So take a second and see if you can set up a proportion and solve. So let's start and see if we set up our proportion right. Someone who has not helped me today, can you tell me what your proportion is? Jaden?
Oh, no. I put 55 and 56.
You put 55 over 56, okay. And you set that equal to? Perfect. So 55 over 56 and then 10x over 44. If you have yours completely flipped, so if you have 56 over 55 and 44 over 10x, that's okay. Okay, so he compared these two because they didn't have any tick marks. He compared these two because they had one tick mark. Okay, now when I cross multiply, I get 560x equals 55 times 44, 2,420. When you divide by 560, I'm going to get a lovely decimal of 4.3. If you reduce the fraction, you would have gotten you would have gotten 121 over 28, and that's fine too, but make it a decimal. Or if it's a hard one, like, I shouldn't say harder. If it's a larger number like that, just make it a decimal. Don't give yourself a headache. How'd we do? Did we set it up right? Yeah? Did we solve right? Yeah? Okay. Questions?